Hello everyone, in this video we will use Laplace transform to analyze the circuit. So in this circuit we have in simple circuit we have one voltage, one resistor and also one inductor. So instruction for the circuit is the task is the initial current is 2 ampere. So initial current means that I at 0 is equal to 2 ampere. Find IT, okay, time domain current. So IT here. So to analyze this circuit we need to use Kirchhoff voltage law, KVL, Kirchhoff voltage law. So we use KVL, this loop, KVL. Okay, we know that for KVL mentioned that total voltage in a closed loop equal to 0 volt. So now we analyze it using KVL. So total voltage here is equal to 0. So we start with this voltage source minus 20 volt. So that's in minus V. So now current, and then plus here, plus voltage drop at resistor is equal to I times R. Okay, then voltage drop at inductor will be equal to, okay, for inductor the voltage is equal to VL equal to L di over dt. Okay, changes of current times inductor, L di over dt. So 1, 2, 3, okay, equal to 0. Then we can rearrange our equation. Will become IT times R plus L di over dt equal to V. Okay, we bring B to right hand side, it will become positive V. So next, just replace the value of R, value of L and value of V. With R is 5 ohms, V is 20, L is 1. So we'll get 5 IT plus 1, so di over dt equal to 20. Okay. Okay, this one is in time domain. So we have differential equation here. Time domain, we have differential equation. So now we can we can transfer to S domain by Laplace transform this equation. So we Laplace for each equation by Laplacing of each one. Okay, Laplace 5 IT plus Laplace di over dt equal to Laplace 20. Okay, now we will get, okay, 5 I, when we Laplace IT we will get 5 IS plus this one is di over dt, first order equation, first order derivative. So we will get S for first order IS minus I0. Then for 20, Laplace 20 will get 20 over S. This one is value for initial condition for current given there is 2 ampere. Given in the beginning is already given, the initial current is equal to 2 ampere. Okay, initial current is 2 ampere. Okay, 2 ampere here. So just replace 2 there. Now we replace I0 with 2. So our equation become 5 IS plus SIS minus 2 equal to 20 over s. Now we can bring s, bring to sec. Now we can simplify is 5 plus s equal to 20 over s plus 2 equal to 20 plus 2s over s. Now is equal to 20 plus 2s over s times 1 over 5 plus s. Okay, is equal to 20 plus 2s over s 5 plus 2. Okay, now this we can do partial fraction equation, solve that equation. So we get 20 plus 2s of s, this one is s plus 5 equal to a over s plus b over s plus 5. Then we do equating here, we get 20 plus 2s equal to a s plus 5 plus b s. So now our s is, we have s equal to 0. So we replace s equal to 0 here. 20 plus 0 equal to a, 0 plus 5, 5 plus b0. So we will get a equal to 4. Then when s equal to minus 5, so 20 plus minus 5 equal to a 0 plus b minus 5. So this one will become 10, this one will become minus 5b, b equal to minus 2. Okay, so we get a equal to 4, b equal to minus 2. So our final equation is equal to a over s, a is 4 over s, okay, plus b minus 2 over s plus 5. Okay, okay, this is in S domain, so we need to convert to T domain by inverse Laplace it. Inverse Laplace of is equal to inverse Laplace of 4 over s plus inverse Laplace of minus 2 over s plus 5. Then we'll get it equal to inverse Laplace of 4 over s is become 4, and then inverse Laplace of 2 minus 2 e minus 5t. Okay, this is unit ampere current. This is the equation for, okay, this is the equation for it. Yeah, find it for this circuit. Okay, that's all. Thank you. Bye bye.